This video is for completing the sample work for Unit 2. Sample work is vocabulary. Write each word, write each definition, and sketch an example of each word. Do that for all the words, the vocabulary words in the unit. You can find vocabulary words as lists of keywords in the lessons, but also as blue highlighted words in the lessons that you can hover over and click on. I'm going to go through them one at a time. Number 1, angle. 2 rays with a common start point. Example, 1 ray going this direction, 1 ray going this direction, common start point. 2. Arc. A piece of a circle. Okay, example, I grab my compass, put my compass point on a point, and draw a piece of a circle. Arc. Circle. 3. All points in a plane, as opposed to in space, equidistant. From one point. Example, put a point on the page, grab my compass, put the compass point on the point, and draw a complete circle. Line. Okay, a line is actually one of our undefined points, but we'll attempt to define it anyway. All points between and beyond 2 points. So if I define 2 points, A and B, it's all the points between them and all the points beyond them. Beyond B, beyond A, going in the same direction. Okay. Number 4. Line segment, or just segment. And I think this one got in there twice. Line segment, all points between 2 points. So I have 2 points, A and B. It's all the points between them. So it has 2 endpoints. Segment 5. Actually, 1, 2, 3. I did 3 twice. 4, 5, 6. Okay. Parallel lines. Two lines, 2 or more lines, in the same plane. That's an important distinction. That never intersect. Example, lines have arrows going forever. I haven't drawn them very straight. I suppose if I wanted to be more accurate, I'd use a straight edge to draw it. But note that they appear to be the same distance apart and remain the same distance apart for their entire duration, which is forever. Okay, number 7. Perpendicular lines. two lines intersecting at a 90-degree angle. Symbol for perpendicular is the square corner. 90 degrees. 8. Point. A locus or location in space. The picture is a dot with a capital letter labeled. Points are always capital letters. Nine. Conjecture. A reasonable guess. I slipped because the floor is wet. Okay, may or may not be true. It hasn't been proven yet. Conjecture. Ten. Definition. A precise statement saying what something is. Square equals a quadrilateral with 4 congruent sides and 4 90-degree angles. Definition. Word and example. Definition and example. Number 11. Cat. Let go. Postulate. Taken as true. Taken as true. Without proof. Okay, we have this statement in the Declaration of Independence. All men are created equal. Okay, which we hold to be self-evident, it says, right? Self-evident means without proof. So that would be a postulate. 12. Oh, I had misnumbered again. I got 11 and 12 mixed up. So this was 12. Let me do 11. Euclidean geometry. Geometry built on Euclid's 5 postulates. Okay, I'll give you an example of Euclidean geometry, a triangle, and I'll draw a parallel to that, and A, B, C, D. This is known as a side splitter theorem. A is to B, as C is to D. It's an example of Euclidean geometry. It's built on Euclid's 5 postulates, which is basically two-dimensional flat paper geometry. Okay, 12, 13. Theorem. A statement that was proven. The triangle inequality theorem. Or let's do the Pythagorean theorem. If you have a right triangle, then a squared plus b squared equals c squared. That's known as the Pythagorean theorem because it's been proven many times in many ways. (14) Undefined term. Any system has to have terms we know without defining them. These are undefined terms. And an example of an undefined term is point. It's a locus in space with 0 dimensions. Okay? Undefined term. And there I go defining it. All right? We define it basically by giving examples and talking about it in detail, but it doesn't have any formal definition. 15. Compass. A tool for drawing circles and arcs. Okay, it looks like this. Has a handle on top, has 2 parts, one that goes down with a pencil, one that goes down with a sharp point, right, and may have some mechanism for changing the radius. Compass. Congruent. Let's make some more space here. (16) Same size and shape. You'll note, by the way, it's made up of an equal sign plus a tilde, which is similar. Equal and similar. Similar meaning same shape. So when you put those together, you get a congruent symbol. An example, this square is congruent to this square. They're the same size and same shape. Congruent. 17. Got to scroll down here. Construct. Use a compass and straight edge to make a precise drawing. Give you an example. 2 points. grab my compass. Actually, grab my straight edge first. I'm going to do the perpendicular bisector of AB. So I'm going to draw an arc from A. And an arc, copy the same arc from B. And draw a line through the two intersection points. That makes what's known as the perpendicular bisector. Okay. 18. Endpoint. The last point or points on a line segment or ray. So line points, endpoint. Endpoint, endpoint, or array, endpoint. Ray. A piece of a line with one endpoint. Okay, I call this ray AB. Starts at A, goes through B. The symbol is AB with an arrow above the B because it goes forever through B. Note we use capital letters only for points. 20, segment. A piece of a line with two endpoints. Point A, point B, and the connecting. This is indicated by segment AB, capital letters, no arrows. 21. Let me make some room. Straight edge. Note that it's one word, not two. Okay, you can think of it as a ruler without marks. Okay, an example is a rectangular piece of wood or metal with a straight edge. It can be a folded sheet of paper or the edge of a card, right? 21, 22. Bisector. Goes through a midpoint. So if I have A and B, and the midpoint is M, then the bisector is anything that goes through that point M. So line L is a bisector of segment AB. 23. Line segment, we've already defined. I'll say C above. 24. Midpoint. Means middle point. Divides into two congruent parts. Example, A, B, and M, where AM is congruent to MB. Midpoint. 25. Segment and bisector. As opposed to angle bisector. Another way, by the way, that brings up something. Angle bisector doesn't go through a midpoint, but it divides into two congruent parts. So that's a better definition. Glad we got that. Segment bisector divides a segment in half. I'll give the same example. A, B, M is the midpoint, AM is congruent to MB. Anything that goes through the midpoint is a segment bisector. 26. Auxiliary line. An extra line in a proof. One of the proofs of the triangle angle sum theorem, if we want to prove that A plus B plus C is 180, we do that by drawing an auxiliary line up here so that this is parallel to this. And then that's a C. Alternate interior angles are congruent. A, B, and C together make a straight angle. Auxiliary line. 27. Vertex. The common or shared starting point in an angle. Remember, we defined an angle as a ray and another ray that share a common starting point. That's the vertex. Angle bisector. Let's go up a little bit again. We're getting close. Oh, we're running out of room. See if we can make it fit. 28. Angle bisector. It's a ray that splits an angle in half. Example, got an angle. It's the ray that goes right down the middle, same vertex, but creates two congruent angles. Angle bisector. Perpendicular bisector. (29). A line, segment, or ray going through the midpoint and making a 90-degree angle. Okay, so if this is A, and this is B, and this is M, the midpoint, okay, it's a line, segment, or ray that goes through M, but also makes a 90-degree angle. That's a perpendicular bisector. AM and BM are the same. Last one. I think we're going to fit it. 30. Right angle. An angle splitting a straight angle in half, 90 degrees. So here we have a straight angle, and a 90-degree angle, or a perpendicular right angle, splits it in half. It's half of a straight line. All right, that's it. Whew, only took 27 minutes.